I've already tweeted out a link to the slides if you want to follow along at home or you're on your laptop in the back. So that's my Twitter handle. My name is John. We're here to talk about DevOps for the Rubyist soul. So I want to go ahead and start with a joke and some audience participation. Raise your hand if you have seen this before and you think you know what it means. All right. Now keep your hand up if you verified the fingerprint. All right. So as I said, my name is John. I work for Braintree. Braintree is a company that helps businesses accept payments online. I'm a security engineer there, although in the past I've done infrastructure, product, lots of different things. So if you are a Braintree customer, I would love to talk to you, get your feedback. Please come find me after this. So every startup has a business plan, and at Braintree, we help these startups with phase 3, which is supposedly where they're going to make their money. But one of the things we struggle with the most is the availability. So we have a very strict control around how available we are. Since we're other people's infrastructure, they rely on us to be up 100% of the time. And we take that very seriously. We try very hard to have no planned downtime. So one of the things that helps us with this is our practice of DevOps. For those of you who don't know what DevOps is, it's the idea that we can take the rigorous, the rigors of agile development and apply it to the complexity of operations and managing server. And some of the ways we do this, which you may remember if you've been doing agile for very long, is something that's automated, repeatable, verifiable. And that oftentimes strikes people as it sounds a lot like testing. Another thing that DevOps does is it tries to help ease the relationship between developers and operations people. Development and operations is really this symbiotic relationship, and that's kind of one of the core ideas behind DevOps, is that we're all on the same team. We can share a lot of the same ideas to get our work done, and there's no reason for us to point fingers at one another. With this presentation, I want to kind of tell two stories. The first one is Braintree's path to DevOps, so how we have developed a DevOps team inside our company. At Braintree, we really love Git, as I imagine many of you do here. We also really love Ruby, which I imagine most of you here do as well. We have a lot of different skill sets on our team. People came to us from many different backgrounds, but kind of the Venn diagram, the intersection of our team is our love of Ruby. And this will help frame the decisions that we made later. As I imagine most of you, we practice Agile. We used to actually have a physical card wall, but now we're on many different locations, so the card wall is virtual, and but the fun continues. Another thing we do that many of you probably do, but not all of you, from what I've been told, is pairing. So we pair on almost all development work, and we even pair on infrastructure work. Certainly we pair on all production infrastructure work. It's really important to have that extra set of eyes and hands around if something doesn't necessarily go as planned. To give you a little bit of history about how we did our agile work, when we had a physical card wall, each card had one of these colored dots. So this is just a pack of these colored dots that you could find at CVS. Each dot represented a separate stream of work. Green was new projects and new features. Yellow was maintenance and support type functions. And blue was infrastructure work. So for the blue, that's kind of, that was kind of where the DevOps work started to land. And what ended up happening is as the team grew and the tasks grew, a sub-team began to form around this specific blue work. So inevitably, we called it the blue team. And the blue team formed as this misfit band of developers trying to figure out what DevOps and how we could define this DevOps culture to our server operations. In the end, we were really just trying to figure it all out together. So the second story I'd like to talk about is my path to DevOps. So I don't just like Linux, I like Linux. If Linux and I had gone to school together, I would have passed Linux this note. Maybe Linux would have gone to prom with me. When I joined Braintree, we were just in the beginning, the primordial stages of splitting into these focus teams. And I would imagine because of my love of Linux, I was sorted and put onto the blue team. But I didn't necessarily know that much about DevOps at the time. Fortunately, I had a great set of people to pair with who helped me, helped teach me the magical ways of DevOps. And if you're a fan of the movie and the book, I do know the scenes are out of order. So DevOps was interesting because it brought with it this whole new set of tools and a whole new vocabulary I had to learn. And we'll actually get to the specific capistrano command later. It's not just a magic saying. So next I want to go over a couple of the tools we use at Braintree to do DevOps, starting with Puppet. For those of you who aren't familiar with Puppet, you may be familiar with one of its competitors, which is Chef. If you're not familiar with either of those, what they are is they're a way to help manage the configuration of your servers and do it in a way that's automated, repeatable, verifiable, kind of going back to what we talked about earlier. So the way, kind of the idea is like Puppet lets you pull the strings with a program on your servers. A common theme is that almost all of the programs we're going to use, you can just gem install. So Puppet is actually a Ruby gem. Puppet is written in Ruby, although the language Puppet exposes is its own language. It's not actually Ruby. Puppet is typically used in this way called Puppet master. And that's where you have a Puppet node that controls many different, each compute node, which would have what is running called a Puppet agent. We do not use Puppet in this way, but I wanted to bring it up in that this is the common way that Puppet is used, and oftentimes when you research Puppet on the internet, they'll talk about it from the Puppet master perspective. The analog with this photo is it keeps all your servers in lockstep, and once you update your Puppet code on the Puppet master node, it will then go make sure that every node runs against that Puppet code. So I'm going to do a real quick dive into Puppet for the uninitiated. This is a simple bit of Puppet code, and we're going to go ahead and break it down. So it's idiomatic to start your Puppet program, if you will, in a file called site.pp that lives in the manifest folder. And we'll go over manifest in a couple minutes. A node is a specific server in your infrastructure. So here we have a server named appo1.qa, and the node is matched based on the host name. Here we're saying we want to install the Ruby package, and this is going to use the operating system's package provider. So on Debian and Ubuntu, it's going to use apt. On Red Hat, CentOS, it's going to use RPM or Yum or something like that. And we're ensuring that this package is installed. Here we're declaring a variable. We're setting the variable blah to test. And the reason is I want to actually use this variable in this file. Here we're telling Puppet we want to manage this specific file. So we're saying Puppet, the contents of this file must always be what we're doing here, which is a template. So Puppet uses herb templates, so it should be very familiar to everyone here. And this is just an example of what I wanted to show. So here we're taking that blah variable, which is now inside herb, and we're putting it in there. So you can think of this like an ini file, or I guess it could be a tomdoc file now. Or a toml, that's what it is. And so we're just echoing out the variable here, and then we actually have a little loop that's going to run. And as you can see, it's just herb. So Puppet lets us pull out things into classes. And so each of these PP files is a manifest. And a manifest is either a set of classes or nodes or things like that. A manifest is just a name for a file of Puppet code. So we want to extract Ruby out into a manifest. So whoever just wants to install Ruby, they don't need to necessarily worry about the details. Maybe we're installing the package and installing some default configuration or some gems or something along with it. They just want to say include Ruby. So we start where, as you can see, this is a different file. We're no longer in the site pp. We're in this new file called Ruby pp. And our class's name is Ruby. Now Puppet will do the smart thing for you. If you're trying to include something with the name, it will go and look for the file of the same name, much like Rails autoloading does for us. And in our site pp, we can just go back and we can say include Ruby. And then the person coding up this file doesn't necessarily need to worry about what's in Ruby anymore. So this lets us introduce abstractions, which we really love as programmers because it helps us remove the burden of looking at a specific piece of code. We don't need to worry about what that piece of code does. Maybe some other person worked on it. I'm worried about just the code I'm working on right now. Another component of Puppet is something called factor. The purpose of factor is to gather information or facts about the system that it's running on. As you can guess, gem install factor, as with most things we're going to use in this presentation, Puppet actually depends on factors. So when you install Puppet, you already get factor. When you just run the command factor, it spits out all of these different key values that it's detected about the system. And it does this in a system agnostic way. So if I ran this on my laptop, it returned this back. I could go run this on a variety of different servers, and it would return back a common set of things that it determined itself, instead of me having to know where on each system it is. In these facts, you can see there's one for my laptop called hostname, which is Apollo. That hostname is how it then goes and matches nodes, which we saw earlier. Another common thing that you see facts used for is if you're running a non-homogeneous set of servers. So maybe you're split on Ubuntu and CentOS. You can apply different Puppet rules to different servers. Here we're using the operating system fact to run certain things on this Ubuntu box and certain things on this other CentOS box. You can also use the facts and templates. So Puppet has this idea called modules. And you can think of them somewhat like gems. Modules are a way of organizing your Puppet code around a certain set of idioms that make them easy to use later. So this would be a typical folder layout for a module. Here under files, we have something I just called some file. This is a file we want to put out onto the server that does not get interpolated by herb. It's just a raw file. Our init manifest is where we jump into the code. So this is the entry point for this module when we use this module later. The next thing is, so the idiom is that you should have a manifest called files. And this is what in your module manages files on the specific server. So if we needed to manage something in Etsy, we would manage it here. The next is package. So any package you would need to install, either gems or like Debian packages or Ubuntu packages, you would do in package pp. And then the next one is service. So if you were going to manage initd services or upstart services or maybe like God services, you would set them up and control them inside service pp. So this is a very simple layout that's common in Puppet for modules. When I want to use it, I go back and I just say include my module. And what that does is it jumps in and uses that init pp as the starting point. So here you can see we've taken a very complex thing out and we've made it just a module. And you can keep going, not worry about how it's actually implemented. A really great resource for this is Puppet Forge. Puppet Forge is where the community has gotten together and is sharing modules. So you can go out here and look for modules to control Nginx, MySQL, Apache, things like that. I would always check there before writing your own module. They have some really great ones up there, so there's no reason to duplicate their effort. Another thing that Puppet comes with is something called Hira. Hira is a way of managing configuration in a hierarchical way. And so I'll explain a little bit more about what I mean by that. And typically you see it used with YAML, which is the examples we're using it with. As you can imagine, it's just gem install Hira. If you wanted to use it in your own projects, you could use it this way. Puppet already, the Puppet gem already depends on the Hira gem, so you don't need to actually install it yourself. So we, at Braintree, we decided to put our stuff in a folder called data. And this is sort of a structure of how one of our data folders looks like. You can see it's just a directory structure of files. Common.yaml is a file that every single server is going to pick up. So these are just shared configurations, maybe NTP settings, something that's very common that you want to share across all servers in your infrastructure. The next one here, you can see if the domain name of the server ends in chai.braintreepayments.com. Chai is just what we call our Chicago data center, which is just our code name for the rack in the back of our Chicago office. So if the server begins with the word DB, it's going to pick up this file. And so DB01 will also pick up this file. So if you think about it, DB01 picks up this file, it picks up the one called DB, and then it picks up the one called common. And it does that in a hierarchical way, where the lower level ones will overwrite settings in the higher level ones. So this is actually an interesting example of how we use Hira. So we use Hira to manage Zen guests. If you're not familiar with Zen, Zen is a virtualization platform that you can use to manage virtual boxes, kind of like virtual machine or VMware and VirtualBox. It just manages the machines for you. So here we have a YAML file where we define some Zen guests. So we defined apo2.shy. And you can see we can interpolate other variables from Puppet. So we have something called gateway VLAN that we're just interpolating. And this configuration is something that is common. So this file is then going to go use, or the Puppet file is then going to go use this configuration data to do something with it. So something one of my coworkers was apt to say, and I steal this from him now because I thought it was really insightful, is Puppet doesn't manage truth. Puppet maps truth to complexity. We really had this problem after a while that we had truth scattered all throughout our Puppet code. And what I mean by that is little bits of configuration were in different files all over the place. There was no one place I could go and say, I want to know everything about what this node's going to have. So now the data directory is the truth, instead of it being scattered in variables throughout all these different manifest files. We then use Puppet to map this truth onto the onto the server. When I first got this, it was like a mind-opening experience. When I fully understood it, it just resonated with me so well. The Puppet lets us build up a model of what we want our infrastructure to look at, and then we use Puppet to map that model onto the actual servers. So as I mentioned earlier, we don't use Puppet Master. We actually are doing our own thing. We ran into problems with how Puppet Master liked to work. Puppet Master is very centralized. It controlled all your servers. It decided when the servers would get the update. We are very sensitive to if services are going to restart on our server, we want to be there to make sure that we can catch problems. We want to be there to know exactly what's going to happen. So we use Puppet in a masterless way. The way we do that is with something we call supply drop. Gem install supply drop. Supply drop, what it does is it marries Capistrano with Puppet and rsync. It's up on GitHub. It was released by a couple of our engineers. And what we do here is we use Capistrano to orchestrate our servers and determine where we're going to run our Puppet, applications. So this is a real simple example. We're going to gem install supply drop. It installs Capistrano. We're going to make the folder that we're in a Capistrano setup, and then we're going to edit the cap file. Basically going over that. So in our cap file, this is more or less something that we use. We define a little macro of sorts called data center tasks. So the first thing we do is require supply drop. In data center tasks, we define a task for the whole data center. If we want to affect the whole data center at once, this is the task that's going to get invoked. The next thing we do is we define a task per server in the data center. And then we use it like this. So in the QA data center, we're going to have Apple 1 QA and DB QA, similarly with prod. So just like earlier, we're going to have something real simple. We're going to install Ruby. As you can, I wanted to point out here, we're actually naming this puppet.pp. And the reason I point that out is in supply drop, it assumes your entry point is puppet.pp instead of manifest site.pp. This was before we actually understood some of the idioms around Puppet. So this is a little bit of old code there. So this is a simple workflow of how we would use supply drop. Let's go through it. So the first thing we do is here we're going to target a very specific server. We're going to target the Apple 1 server in QA. So we run what is called a Puppet no-op. We on our team pronounce it noop. It's just what we ended up going with. It's, I guess, one less syllable. So we say, all right, I'm going to noop this server. What will happen is Puppet will go out. It's going to supply drop is going to rsync your local Puppet folder up to the server, and then it's going to run Puppet locally, targeting just that server. It will then spit out to you the diff of what it wants to do on that server. If nothing wants to change, it'll say, I'm finished. I don't want to change anything. So you know that your Puppet code that you just did doesn't actually affect this server. In this case, it's going to say, Ruby is not installed. So current value is absent. It should be present. I'm going to install Ruby. When we're ready to do this, we Puppet apply. It goes out, it runs the same thing, only instead of giving us a diff, it actually runs the commands to install. After that, we nuke the entire environment. This is just our way of knowing that what we just wrote doesn't affect anything unwillingly. We make sure that we're not going to cause a problem later, that we're just leaving bad code around like a mine for one of our fellow coworkers. After that, we just do a git commit. Normally, I would use a better commit message than this, but I had to fit it on the screen. And we add it, commit it, and we push it. So now everyone on our team has the same commit and has the same understanding of what the server configuration should be. So this is just a couple more examples. We have a different server. This time it's DB01. We're just going to nuke it. Through the power of shell expansions, here we're nuping on the second line every app server from 001 to 12. So we're saying, I want to nuke this entire range and see what's going to change. We can also nuke the entire data center. And then just to remind you that we're just dealing with capistrano, on the bottom one, we can run ls on every server in the infrastructure or in the QA data center and just get back what ls says. This is kind of that's more like a blunt hammer approach. If we just need to see what's in a specific place, we can use things like that. So we use Git to share our changes between each other, and we run this. This lets us do a distributed server configuration. We have a branch per environment. So when you're running things against QA, you're going to use the master branch. When you're running things against staging, use the staging branch, and production, the production branch. This lets us do things like when we're ready, we merge things between the branches. So we've tried out our changes on QA. Now we're ready to take them up to staging, where we're actually going to affect some customers who are just integrating with us, running trials. In production, we're actually affecting real customers. So here we merge master. We see what's going to change in staging. And then we would normally selectively apply, but here you can see we're applying all of staging and then pushing. So we're now going to make staging, our local Git copy. Just going through what I just said. So Git, as I mentioned, lets us work in this decentralized manner. So if you were working on a different environment and a different set of servers from someone else on the team, you won't conflict with them. And this lets us kind of separate our work. If you are going to conflict with them, supply drop actually will lock the server while you're running on it and let you know that someone else is trying to puppet that server. And that helps prevent us from just clobbling all over each other. The other thing you can do is just stand up and say, hey, in our chat room, you'll see someone say, hey, I'm nooping sandbox, or today I'm going to merge, or staging. I'm going to merge staging up to production. This process of merging is something we have come to call going up and down the infrastructure. So we try to make sure, ideally, that we go up and down at least once a week, and that way we can make sure that we're not leaving any massive diffs or kind of a minefield later. And so this is kind of what it looks like logically. So in our terminology, production is always up. You don't want to say production and down in the same sentence. People from across the room will all of a sudden just hear that and like jump up. So QA is down. So when you're going from QA to staging, it's a little bit more loose. But when you're going from staging up to production, this is where you want to make sure that you have a pair. It's where you want to make sure that you have an extra set of eyes. So I like to call it the danger zone. Are there any Archer fans? Yeah, all right. So you always want to have an extra set of hands around to make sure that things are going to go well. Always have a plan. So here are some of the lessons we learned, and I'll go through each of these. Stick to the Puppet style guide. This is something that we learned, we kind of fell onto later and didn't learn fast enough. There's a reason you write idiomatic code, and that's to ease the way that everybody communicates together. So without the idioms, you tend to apply your own, and every person ends up applying their own. It doesn't mesh together well. It also helps keep your Puppet repository clean. Use modules. Early on, we didn't use modules effectively. Modules let you compose together things very effectively. You can choose these generic components from Puppet Forge and things like that, and then you compose them together to make your own services. So, for example, I'm running my product. Well, my product requires Apache, a Unicorn, a Postgres, and we kind of compose them together to make the service for this project. Next is turn on Puppet backup. Puppet, if you ask it to, will keep a version of every single file that has changed on the server. So this has saved us more than a few times where we can just go back and grab the file that we just changed, what it was just before we changed it. It sucks for large files, obviously, so you can turn it off on a per file basis. And the next and last one is merge regularly. You don't want to leave these mines around in the infrastructure. Just like why we deploy often, the faster that you get through this, the better you can get at iterating and getting it through. A smaller change is going to be less scary when it comes to go to production. So the last thing I wanted to talk about was vagrant. Who here uses vagrant already? All right, so that was pretty good. So vagrant helps you automatically build VirtualBox and now VMware, but VirtualBox boxes on your local machine. So you can gem install vagrant, although they tell you not to do this anymore. You should actually go to their website and download it. The version in Ruby Gems is no longer the current version. They prefer that you install it this way. For the uninitiated for vagrant, here's a real simple use. I'm going to initialize a new box using precise 64. So this is what is called a base box. So it's going to spin up a new Ubuntu precise 64-bit server for me on my local machine. Up is going to turn it on, get it all spun up, and then vagrant SSH is going to let me jump onto that box, just like I would SSH onto a server. So here's a simple vagrant config file. These are stored as vagrant file. Here we're just saying our base box is precise 64. In many cases, you may want to build up your own base box. And we're actually going to spin up two virtual machines, one named web and one named DB. And this also will forward some ports from your local machine to the VirtualBox or to the virtual machine so that you can run and act on it as just if it's on your local machine. So Vagrant also has something called provisioners. When you spin up the Vagrant box, it can run a Puppet apply for you on that box. It can also do Chef, and I think there are others. But in this case here, we're just saying you can find our manifests in the manifest folder, and when you want to provision this box, just run Puppet pp. So Vagrant lets us do a few things. The first one is rapid prototyping. A lot of the cool software, like the cool new things, are clustered software, so like RabbitMQ, React, things like that. And so when you're testing them, you want to make sure that you test them in a cluster configuration. Vagrant lets you really quickly spin up these boxes, get them to a common configuration, and then get them talking. And you don't then have to like pay the EC2 bill and then forget to turn them off and end up getting a nasty email later. The next one that I'm seeing more and more of these days is using Vagrant for a dev box. On our team, we've recently switched to this approach. This lets us develop and run our code locally on the same type of server or the same type of machine that we're deploying to, which is Debian and Ubuntu machines. The box, it could be managed via Puppet, so new developers get up and running really quickly. They just go download this box, spin it up with Vagrant, and it gets Puppet applied with the latest changes. This is a much faster, much easier mechanism. Though when you used to start at Braintree, there was a wiki, and you would go step by step, homebrew, like I see a lot of heads nodding. And then when there was a mistake, the answer was, hey, it's a wiki, go update it so the next person doesn't have the same problems. Now the wiki for us essentially has one line, which is install the dev box. So in closing, I want to share with you a little bit of DevOps humor. So there's a Tumblr called DevOps Reactions. So I highly encourage you to follow it. This is one of the more recent ones, visiting the guy who wrote the build scripts. Another one is DevOps Borat. So if you may know Big Data Borat, I highly recommend also following DevOps Borat. And then this is probably my favorite, more recent one, DevOps from the Swedish fiddles with Ruby scripts until the EC2 instance deploys. So that's all I have. As I said, my name is John Downey. I work for Braintree. I think I have around 8 minutes for questions. So if you guys have any questions, I'll try to remember to also repeat them. I see no, oh.
Do you have developers that were complaining about performance issues with Vagrant?
We have. We also, yeah, I'm sorry. He asked if we had developers who were complaining about performance issues with Vagrant. We have had that in the past. The quickest way to solve that is you can go and change the virtual machine, up the processors, up the RAM, and then at that point, we really haven't seen that many performance issues. We also, when we're doing a lot of our developments, we're doing them on Mac Pros, which are already pretty speedy, but there is, as you rightly point out, a layer now in between you're running on a virtual machine, but it hasn't been that big of a deal. Yeah.
I noticed you were running your the processes from the local box. What are you doing to prevent overwriting? One op releasing, and if they don't follow best practices, accidentally having someone else overwrite their things that you're following.
So we actually run, he asked about how do we, he said that it looked like we were running our operations from the local box, and how do we prevent people from overwriting? So we actually end up running our operations from a Bastion box. So it's actually inside of our infrastructure. You can only SSH into one box inside of our data centers that's really heavily protected, but it's still the same thing. For keeping people from overwriting, supply drop has a lock. So when you hit that server, there's a lock. And now you've locked that server until your Puppet operation finishes. So if you try to hit it in that interim amount of time, it'll stop and tell you that you've been locked. And after that, you're then going to see a diff. So everybody else who hits it is going to see that something changed that they didn't expect to change, and that's when you start communicating. You go into the chat room, you say, hey, is anybody else hitting this box on QA? I see something I didn't expect. So that's kind of how, before we had the lock in there, we used to just clobber each other quite a bit, but now it hasn't been that big of a deal. All right, so I don't see any more hands up, so I'll be around up here out in the hallway, so if you have questions, I'd be happy to answer them there. Thanks.